This is about assumptions, both research assumptions and statistical assumptions. These are important in the conduct of social science research. Now, the research assumptions, it's first of all context bound. So what is the context that the research is being conducted, where it is conducted, what is the cultural milieu in that particular location, and the people involved. That's important consideration. Research is based on inductive forms of logic, that is from the specific to general, or from simple to complex. Categories of interest may emerge from informants, that is internal, or be used to frame an understanding, that is external, from the researcher. Whether it is appropriate to use various statistical tests depends on the characteristics of the data being analyzed. Basic assumptions about the data must be fulfilled for the test to be meaningful. Now, assumptions for parametric tests is that before conducting any parametric analysis, explore the data to ensure that certain assumptions are met. The parametric tests include some of the most commonly used analytical tools to compare groups of data with continuous variables. We know how different is continuous from discrete variables, like age is a continuous variable. Okay, measurements are continuous, weight continuous. So it all depends on the characteristics of the data. Now, a two-sample t-test, we know that there are other types of t-test, like there's the paired t-test, right? So this one, the two-sample t-test is used to test whether or not the means of two populations are equal. This type of test makes the following assumptions about the data: independence, normality, homogeneity of variance, and random sampling. Now, as to independence, the observations in one sample are independent of the observations in the other sample. So this should be two different samples. As to normality, both samples are approximately normally distributed. Homogeneity of variance, both samples have approximately the same variance. Remember variance? It is one of the measures of dispersion, right? That after variance, you compute standard deviation, which is just the square root of variance. So how far, or it's the distance of other elements from the center of the data. So random sampling, both samples were obtained using random sampling method. We know there are many ways to conduct random sampling. If one or more of these assumptions are violated, then the results of the two-sample t-test may be unreliable or even misleading. Now, the first assumption on independence. So in detail now, we are going to discuss this. So in here, the two-sample t-test makes the assumption that the observations in one sample are independent of the observations in the other sample. This is a crucial assumption because if the same samples appear in both samples or the same individuals, then it isn't valid to draw conclusions about the differences between the samples because you're comparing the two same people. So how to check this assumption? The easiest way to check this assumption is to verify that each observation only appears in each sample once, and that the observations in each sample were collected using random sampling. So as a researcher, you know how you did that, how you did your sampling. So what to do if this assumption is violated? If this assumption is violated, the results of the two-sample t-test are completely invalid. In this scenario, it's best to collect 2 new samples using a random sampling method and ensure that each individual in one sample does not belong to the other sample. As you can see, this is not good, right? Because it takes time and, of course, budget, especially if your sample is 300 and you are going to repeat that. Now, as to the assumption 2 on normality, a two-sample t-test makes the assumption that both samples are approximately normally distributed. This is a crucial assumption because if the same samples are not normally distributed, then it isn't valid to use the p-values from the test to draw conclusions about the differences between the samples. Okay, how to check this assumption? If the sample sizes are small, that is below 50, then we can use a Shapiro-Wilk test to determine if each sample size is normally distributed. If the p-value, that is the result of the computation, is less than a certain significance level, then the data is likely not normally distributed. Now, if the sample sizes are large, then it's better to use a QQ plot to visually check if the data is normally distributed. So that is how a normal QQ plot looks like. Now, if the data points roughly fall along straight diagonal line like this, in a QQ plot, then the data set likely follows a normal distribution. You can do this very, very fast in a statistical package for social sciences software, or the SPSS. That is software that I've been using since the early 90s, actually. But then that time, that was still in a programming mode, that is in this operating system mode. Unlike at present, wherein it's Windows based and you just need to click, 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 and it's fast. But you can also do this checking of the assumptions using Excel, but it's very tedious. What to do if this assumption is violated? If this assumption is violated, then we can perform a Mann-Whitney test. So mean to say, it's not that your data becomes unusable. No, you can just use the two-sample t-test, but you can still perform a Mann-Whitney test, which is considered the non-parametric equivalent to the two-sample t-test, and does not make the assumption that the two samples are normally distributed. So it's just about what the appropriate statistical tool you can use based on the assumptions, whether it's followed or satisfied or not. Now, as to the third assumption on homogeneity or variances, a two-sample t-test makes the assumption that the two samples have roughly equal variances. So the rule of thumb, if the ratio of the larger variance to the smaller variance is less than 4, then we can assume the variances are approximately equal and use the two-sample t-test. So that is how to check it. Suppose sample 1 has a variance of 24.5 and sample 2 has a variance of 15.2. The ratio of the larger sample variance to the smaller sample variance would be calculated as ratio 24.5 divided by 15.2 equals 1.61. Since this ratio is less than 4, we could assume that the variances between the two groups are approximately equal. And this is easy to use because we know even how to compute the variance in a manual way, right? You just use the mean of each of the group. You can have variance already. So this is easy to do. Now, what if you have violated? So what do you do? If this assumption is violated, then we can perform a Welch t-test. So it is still a t-test, which is a non-parametric version of two-sample t-test. So your research is still okay. and this does not make the assumption, the Welsh t-test, that the two samples have equal variances. Now, the fourth assumption on random sampling, because this sample t-test, two sample t-test makes the assumption that both samples were obtained using a random sampling method. So to check this assumption, if it's met, there's no formal statistical test for this assumption. Just make sure that both samples were obtained through a random sampling method, which you as a researcher know, such that each individual in the population of interest had an equal probability of being included in either sample. Okay. Now, what if you have violated this assumption? Then it's unlikely that our two samples are representative of the population of interest. In this case, we can't generalize the findings from the two sample t-test to the overall population with reliability. So in this scenario, it's best to collect two new samples using random sampling method. So of course, again, time, budget matter a lot. So by the way, I hear this normal distribution diagram. So just to understand better about the tail, one tail, two tails, the whole area, just a review, no, is equal to 1. Each half is equivalent to 0.5. This half. So this is 0 here, and then suppose that these are the labels here. Suppose this is okay. The negative side, this is negative actually, 0.025 area, 0.025 this right side. So this one is the one of the tails. Now, if you use both, it becomes two tails. So why we have this 0.025? Because actually it's on the level of the alpha level that you set, the researcher set for 0.05. So 1 minus 0.05, suppose you divide that into 2, the 0.05. So you have this 0.025 here, right side positive, and the left that is negative. So what's left after you deduct, you subtract, the 0.05 will be 0.95. So this area here will be the 0.95. Okay, and that will be, this one will be the area of rejection, and this one the area of acceptance. So if the p-value will fall here, so you are in the area of rejection, that you reject the null hypothesis, because usually the researcher will phrase the hypothesis in a null as a null. No, there's no relationship. So when you reject, so it means there is a relationship. Okay.